Hi, I'm Neil Fourie. I'm the Group Head of Innovation at HC, and today we'll be learning about how to calculate the thermal load of a cold room. A cold room keeps things cold by removing heat. The thermal load is all the heat the cooling system needs to remove to keep the cold room at the right temperature. Here's a simple guide to the main sources of heat in a cold room. Transmission through the walls, roof and floor. What is it? Heat sneaking in from the warm outside through the room's walls, roof and floor. How it works. Warm air outside tries to warm up the cold room. Insulation slows this down, but some heat gets through based on the wall's insulation size and the temperature difference. The equation to calculate this is Q of transmission, being the heat load, is equal to UA times delta T. U is the conductivity of the insulation, A is the surface area, and delta T is the temperature difference from the inside to the outside. Product load, or pull down. What is it? This is the heat required to cool products like food to the cold room's temperature. How it works. Warm products need cooling. The heat depends on their weight, material, and how much they need to cool down. The equation Q of the product is equal to M times C times delta T, where Q is the heat load, M is the mass of the product, C is the specific heat of the product, and delta T is the temperature change. 3. Product respiration. What is it? This is heat produced by breathing products like fruits and vegetables. How it works. Living produce generates heat as it respires. The amount depends on the product type and the weight. The equation is Q of respiration is M times R, where Q is the heat load, M is the product mass, and R is the respiration rate of the given product. Miscellaneous heat loads. What it is. Extra heat from lights, people, or equipment. Things like opening doors or running machines add heat. Each source contributes a small amount. The equation is simple. The total heat load of the miscellaneous heat loads is just the sum of all of the heat sources. An example is lights at 100 watts, people at 100 to 250 watts, and door openings can be estimated. The total thermal load is calculated by adding all of these together. This helps size the cooling system to keep the cold room at the right temperature.